Hi everyone, and welcome to another video for our unit on matter and change. If you're watching this video, then you've just completed the chemical reaction. You just completed the lab for the chemical reactions, and you worked on writing word equations and solving problems using the law of conservation of matter or mass. So what we're going to do now is I'm going to move you on to solving problems using the formula for density. I would like to remind you that density is a physical property, which means you don't have to react your matter or your stuff with any other material in order to determine or measure the object's density. And when you're measuring density, you're measuring how much mass of a substance occupies a certain volume, how much stuff you have per unit of space. Density, mathematically, the model we have is density equals mass divided by volume, or in a short form, D equals M over V. Please be aware again that density is a physical property, so therefore, since it's an intensive physical property, it can be used as one property to help identify an unknown substance. Density changes slightly with temperature and pressure, so it's important to be aware of if your temperature and pressure are, at standard, at room temperature, because the density amounts or values that you have for a given metal, say in your textbook, are all taken at standard temperature and pressure, and that's pretty much at room temperature. So just be aware of that as you're, if you're in the lab and you have to identify an unknown material, that you know what temperature you're working with. So when heated, most solids and liquids expand. We learned that in the energy unit. And this is one of the beautiful things I think when you look at an equation of density equals mass over volume, is that if you increase the volume by heating the object, then your density will decrease. And that's just the relationship between D equals M over V. Your denominator, if that decreases, and your numerator, M, remains the same, then your ratio or your quotient of those two quantities will decrease. So it has an density has an inverse relationship with volume if matter stays the same, and it has a proportional relationship with mass when volume stays the same. So this change is usually too small to be noticed in solids and liquids, but we absolutely can see that difference with a gas. Just think back to when we had the balloon and we put we blew up the balloon and we heated it and then we cooled it. You absolutely saw that there was a change in volume, and that change in volume greatly affects the density of the gas. Here's just some sample problems, mathematical problems that we are going to do in class and, well, you're going to do in the video. A piece of lead has a mass of 22.7 grams. It occupies a volume of 2.00 cubic centimeters. So what's the density of lead? You want to remember the formula, which you are going to have to memorize. Any 9th grade science student needs to know the formula for density. And you want to plug and chug into that equation and do the math, solve the problem, and then round to the correct number of sig figs. So here we have 11.35 is the raw number from your calculator, and we round to 3 sig figs because there's 3 sig figs here, 3 sig figs here, so our answer can be expressed to 3 significant figures. Don't forget, you always want to have your units here, grams per cubic centimeter, mass per unit of volume. Problem 2. A piece of lead occupies a volume of 4.0 cubic centimeters. The density of lead was determined in the above problem. Remember, it was 11.4, so what's the mass of lead? You have to just algebraically manipulate the equation to get M by itself, and I'm pretty sure you can do that. So mass equals density times volume, because remember, you want to just multiply by V on this side of the equation and multiply by V on this side of the equation. The V's cancel out and you're left with mass equals density over volume. Or you can plug in your numbers and solve for X, whichever way you want to do it. So your mass here is equal to 11.4 divided by 4. Notice your cubic centimeters will cancel out and you'll be left with grams. You also want to round to the correct number of sig figs here. Since you're limited to 2 in the measurement for volume, your answer needs to be expressed to 2 significant figures. Problem 3, that same piece of lead has a mass, not that same piece, but that same material lead with a different sample has a mass of 302 grams. The density of lead was determined in problem 1 Remember what that was? That was 11.4. What volume does it occupy? So now you're solving for V. So if you take it from mass equals volume times density, you want to divide by D on both sides, and you end up with mass divided by density equals volume. Plug and chug into your equation, your grams cancel out, and you're left with 26.49 cubic centimeters, round to the correct number of sig figs, which is 3, because you've got 3 here, and you had 3 in this measurement as well, so that comes out to 26.5 cubic centimeters. Okay, so what you're going to do now is, now that you know how to, or you've reviewed how to solve for the quantities of density, mass, and volume using the density equation, I want you to go over to the lab, which is determining the density of unknown metals. And you'll see that there are some samples there, and the purpose of the lab is for you to find both the mass and volume of several, I think we're going to have just 2 or 3 unknown metals, and from these measurements you're going to calculate their densities. Then you're going to use the chart below, which is on your lab sheet, where I've given you the name and the density of known metals. You're then going to compare your lab value, your experimental value, to the actual or accepted value to determine the unknown metal. Once you're done that, you're then going to do a calculation for percent error, and you've done this before. It's just your observed value minus what you got, what you should have gotten in lab, or your true value divided by your true or actual value multiplied by 100. You'll see that on the analysis questions. And then once you're done that, you've got some problems to do for, just kind of computing density, solving problems using the density formula. And then, of course, last but not least, you're going to be doing some graphing for me, which is you're going to do a multi-line graph for 5 pieces of aluminum, and you are going to have to answer some questions by interpreting your graph. Okay, so there you go. I hope that was helpful, and okay, so off you go on doing the density lab.